Yeah, I'll let you know what Meva Energy is. But first of all, I just want to ask kind of a basic question, maybe a philosophical one, or theoretical one at least. But what do you think is the best use of biomass for any purpose, really? Generally, what you say is that the best use of biomass is materials production, right? To produce wood beams, planks, building materials in particular. Things like this, is most likely the most high value object you can produce from something out of biomass. But when you do that, and when you manage your forest, you end up with forest residue as well. You can't use all your biomass for materials production. And what you then have to sort to is the production of energy. And speaking about rephrasing that question a little bit then, what is the best energy use of biomass? That's a completely different question. And then let me argue that the best use of biomass for energy purposes is a type of use and a type of application where you replace fossil energy use with the biomass. That's the first one. Where you do that at a high efficiency. As much as possible of the primary energy in the biomass should be used to replace the fossil energy. The third one is that you should have a technology that also enables you to create a carbon sink. We need to get rid of the CO2 in the atmosphere. We need to put it back into the ground in one way or the other. So that's the third one. And the fourth one is that you should use a technology that also allows you to use waste materials, even contaminated biomass, for those purposes. If you end up having a technology doing all of those four things, meeting all of those four targets, then I would argue that it's the best way to use the biomass next to production of 17th century furniture, maybe. So yeah, that was just like putting it context into this presentation of Meva Energy. So this is what we are, the most climate-friendly renewable energy technology you never have heard of. I claim to say that because we are not a listed company, and that kind of puts us off the radar for a lot of people. But we are a Sweden-based company. We were founded up north as a spin-off from Luleå University of Technology many years ago. We're now based in Göteborg, and we have presence also in Östergötland, where we have built our first commercial plant. All right, again, going back to the philosophy here. Imagine this. Imagine a technology that meets these criteria. It directly replaces fossil energy. It does that at high efficiency and at a relatively modest capex. Relatively. We talk about energy transition here. There are some enormous large projects out there, as you know, in particular within hydrogen, of course. It enables carbon sequestration, carbon sink creation, that is. A technology that stands at a relatively high readiness level, technology maturity level. In our case, it's between 8 and 9. And you do that at a relatively low cost per kilograms of CO2. That's also a criteria. You need not only to be able to produce renewable energy, you need to do it at relatively low cost, right? And the last one is pretty nice. You have to remember as well that biomass is nothing else from an energy perspective than stored solar energy. That's the purpose of the photosynthesis. I assume most of you guys, you learned about that in school some years ago, right? So that's what, and we meet these criteria. This is what we do at Meva Energy. Short about the company, we are, as of today, 45 employees, based in Gothenburg, have our origin in up north then, and we apply a type of gasification technology that is referred to as entrained flow gasification. You have been listening to Rolf and to Henrik here. You could say that all of these three companies are like cousins within the same family. We all do gasification. We do it in a little bit different ways. And our model is what is referred to as entrained flow. I'll explain what that is later on. We have done the complete kind of cycle going from R&D to pilot test in small scale together with rice to large scale trials with a full scale plant actually up in Piteå. And now we have built our first commercial scale plant as well. That is a plant that is located in Kisa, not Kista, another part of Sweden that is, outside of Linköping, and it's hosted by a soft tissue paper producer called Sofidel. It's a big Italian producer of tissue paper. So what that plant is doing is that it is producing a kind of a raw biosyngas that directly replaces the use of LPG, gasol, in the tissue mill. So when you dry tissue paper, you need to blow a hot stream of air onto the paper trail, and that hot stream of air is now being produced with biosyngas instead of LPG. So it's a direct replacement of a fossil energy source. We also have a commercial agreement with IKEA Industry in Poland. So we are building the second plant with IKEA's flagship factory in Szpontynek in Poland. It is to be commissioned mid-2025, so about a year from now. We should be close to the commissioning date of that plant. That plant is a little bit different because it utilizes scrap fiber and scrap particles from the production of furniture directly within the IKEA premises. It's an extremely circular and elegant solution. IKEA came to us a few years ago. They pointed at those big piles of furniture dust, MDF residue, and asked, what can we do about it? We've heard about your entrained flow gasification technology. Could this be applied? It took a few years of pre-studies and learning how to do it properly, but now we are to build this second plant within their context as well. Good, strong customer of ours. So basically, these two examples also illustrate the two application areas which we have with Meva Energy. Either it's about production of biosyngas to replace manufacturing industry's use of natural gas or LPG, or it's about production of biosyngas for the purpose of power and heat production within an industrial entity that itself produces the bio-waste. That's the IKEA case. So one is about gas production, the second is about combined heat and power. Yeah, so that's what we do. And what about the graph here? What does it say? Well, this is you have to talk about you can't just sell these stuff based on the green values or the carbon, the low carbon footprint of it. You have to be competitive also price-wise. If we use a low cost or even negative cost feedstock, like we do with the IKEA case, then we are able to produce power at a very, very low cost. So this example here with the 15 euros per megawatt hour production cost for power with the IKEA case, that's of course extremely low. Put it into Swedish context, and that's approximately 15 öre per kilowattimme. So it's a very low production cost of green electricity. That's only doable if you use a negatively priced waste feedstock to start with. Otherwise, you can't achieve that. Right. Many partnerships out there. This is relatively capex intensive development. You can't do it yourself. You need to team up with a whole lot of other companies out there. We have close ties to the Royal Institute and to RISE, but also more importantly maybe to Andritz and to our turnkey production company or supply company, our EPC to JCP in Czech Republic. Right, a lot of words about that slide. Here's the plant. Here is our first commercial plant hosted at Sofidel. This is the nice view from the old villa of the owner of the paper mill. It was commissioned last year in October. The first week of October was the first week when anybody were able to dry tissue paper with the use of biosyngas. So it was a really big moment for us being able to prove that concept. You know, tissue paper, or in Swedish, mjukpapper, that is what you use in everyday life. You use it for hygienic purposes, you use it in the kitchen, you use it to wipe your nose, right? And one key question from Sofidel's point of view when we entered discussions with them was the risk for bad smell. After all, biosyngas is not from a chemical point of view as pure as LPG. So was there any risk that their high quality tissue paper would have a bad smell? We needed to find out. So we set up, first of all, we tested to dry the paper using biosyngas in a pilot plant. And then we set up like an odor panel, almost as many as you guys here. And each and every one had to take a sniff of a piece of paper, make a review afterwards. Does this smell bad or not? It was a critical moment for us, and it was also very, very symbolic. Would we have a problem with bad smell or not? But at the end of the day, the story ended in a good way for us. So there was no indication at all of any bad smell. But that was the most important hurdle for the tissue industry before kind of trajecting themselves into this industry. Now we have a relatively strong position, I would say, within that industry. A lot of companies producing tissue paper in the world know about Meva Energy. We have been covered within their the relevant industry magazines, and we are also a present representative at the relevant industry fairs and so on. So we mean now to harvest on that position. It takes some time before you end up having an industrial position within a certain industry. We are here now within the paper industry. Yeah. Okay. So how does it work for all you techies here? It's relatively simple. This is the gasification vessel. It's relatively small given its output. It's a 5-meter high vessel. You inject a pre-made mixture of fine fraction biomass, so that is biomass sawdust, and air into the top part. You do it at a high speed. You create a swirling moment as this mixture spins down into the vessel. At the same time, you have this conversion between solid biomass and gas. So the gas is effectively created within a few seconds only. After it exits at the top part, it turns around at the bottom and it exits at the top part. And at the bottom, you also have a production of biochar, which is, let me come back to that, what that is later on. Right, here's the plant. I wanted to show you this picture because it's pretty interesting. You see the whole plant structure, all the metal beams, the steel works, but the gasification vessel, that's this one. It's very, very small. So there's a lot of, actually we built the plant with the purpose to enable introduction of a second gasification vessel later on if you wanted to. But it's a very very neat construction, a lot of output given its size. Yeah. Let me say something about this. I have this one as well. So this again going back a little bit to all the alternatives out there in the energy business, in the energy sector. What racehorse is the best to opt for? Which different technologies should one choose if you're in a certain position? Everybody is making their own case, of course, but I'd say that, and I think it's pretty fair to say that biomass gasification is largely forgotten in Sweden from an application point of view. You don't hear as much about it as you do about nuclear or hydrogen. Those are the two big ones right now. That's where the trend is. But inherently, I would say that the greatest future is for biomass gasification still. One very important reason why companies like ours sometimes need a lot of time to achieve market maturity is that the timing is not entirely correct. And I would say that the timing now is getting better and better and better each and every day and week for this type of technology. It's being pushed. If you look at the debate about how to decarbonize Swedish energy use. A lot of it has been focused on the transportation sector for many, many years. Now that is being switched to the industry sector instead. That's exactly the kind of switch that benefits, that is advantageous for Meva Energy and most likely also for Cortus and Phoenix, right? So there are some very good things ahead of this sector, and it's obviously also much more mature than in particularly hydrogen. That's a constant topic. Okay, final slides here. The biochar, I need to say something about that. So biochar is a type of charcoal that exists at the bottom of our gasification vessel. If you would have a conventional boiler or a conventional panna or kamin, then the residue would be ashes, right? The biochar is the equivalency to ashes. It's a solid byproduct that contains sufficiently high amounts of carbon, making it qualified as biocarbon or biochar. And if you store this biochar in the soil or basically anywhere, you just don't ignite it afterwards, then it remains stable. It does not degrade. If you put a piece of wood out in the nature, it will eventually degrade, forming CO2, going up into space with no use at all. But biochar is solid. So one way to achieve a carbon sink is to use the biochar for soil improvement. It even has functional properties, increasing the ability to grow things on poorly used farming soil. That's an extremely important benefit of biochar. So it's a very, very good byproduct to have. And interestingly enough, only a few weeks ago, the EU Commission expanded the certification framework for what technologies that are being allowed to be called carbon dioxide removal technologies. And biochar is now one of them. It started out only with a few other ones, but biochar is now qualified. So, and that also means that the future demand for this will certainly increase. Maybe the last slide here. I think I'm using up almost all my time. This is a nice picture of a sheep, right? How come? Well, again, the biochar. If you use the biochar as food additives for ruminivores, idisslare, then the production of methane within the digestive systems of those animals decreases. It decreases with up to 20%. And the production of methane at farms, at sheep farms, cow farms, pig farms, is the most important source of greenhouse gas emissions within the farming sector. So this is actually pretty amazing. You just use 1% of biochar, you add 1% of biochar to the feed of those animals, and you're able to decrease the production of methane from the digestive systems with up to 20%. This will be a big thing for the future. You will read a lot about this a few years from now. Trust me, I'm sure. Okay, that's it.
Thank you very much.
Yeah.
Before we start the panel discussion, I would just start with one question here, and that is, you are not listed or quoted. So if one has an aspire to invest, what should one do?
We're not listed now. We think we will do a new investment round next year. There is a possibility that that round also will involve, a public offering. So that's maybe the reason why I'm here, basically addressing, general public like this.
So one should watch the space of MEA on the webpage.
Yes, absolutely. Yeah.
Excellent.
Yeah.
And you mentioned IKEA and Sofidel. Who finds who here? Do you knock on the door and say, we have this beautiful technology? Or do they realize that we have a lot of, leftover when we make our furniture, we need to do something? And in Sofidel, they need a clean, good smelling paper. I mean, how does it work?
Yeah, that's a very good question, actually. And the answers differ from those two cases. With IKEA, it was actually them finding us. So they had set up this internal project trying to identify various technologies of interest, and they obviously found us then. This was back in 2016, so it's been a long story with them as well. With Sofidel, it was the opposite. It was basically us testing out the concept with a few tissue paper producers, and Sofidel, being a family-owned company as well, they were quite quick on that one. So, yeah.
So it smoothened up the process a little bit.
Yeah.
Okay, excellent. Thank you so much, Niklas. And now